So a water molecule sort of looks like Mickey Mouse, the head being an oxygen and the ears being hydrogen. The oxygen has a slight negative charge, while the hydrogens have a slight positive charge. The oxygen has a very high electronegativity, which is why it strongly pulls, so to speak, the hydrogen towards it. Now, the slight positive and negative charges on the molecules help to create the hydrogen bonds. And these bonds are very weak. So when water freezes at 0 degrees Celsius, it is known as ice. This is when it's not very dense because the water molecules freeze in a lattice structure with hydrogen bonds. There's kind of sort of holes in the structure when it freezes, so it floats when you put it in liquid water, because in liquid water the molecules group together. And even though ice is not very dense at 0 degrees Celsius, it's its most dense at 4 degrees Celsius when all the clusters are coming in tightly packed right before it's about to freeze. Liquid water is more densely packed than ice is, and this is because it isn't in a frozen state, so all the molecules are moving about and whatnot. It's most dense at 4 degrees Celsius, and that's because it's when all the molecules are starting to come together and form groups right before they freeze into their lattice structure. The reason why water sticks to water is because of cohesion. Water is attracted to itself. But then there's also the matter of adhesion, which is water sticking to other things, and which is the reason why some bugs can walk across water and also some lizards can walk across water. So that was adhesion, where the lizard runs across the water. He can't really walk across it, he has to run across it, but he still gets across the top of the water. And that's also known as surface tension, and this happens because there's no more water molecules above the water to stick to, so the water is just looking for something else to stick to, so things like the little lizards and bugs are able to stick to the top of it. Another example of surface tension is when you are able to fill your glass a little above the rim, and this is because the water just all stays together so it won't overflow out of the rim thanks to hydrogen bonds.
I see trees of green, red roses too. I see them bloom for me and you, and I think to myself, what a wonderful world. I see skies of blue and clouds of white, the bright blessed day, the dark sacred night.
So when water reaches 100 degrees Celsius, it starts boiling. The boiling happens because the hydrogen bonds are constantly breaking and reforming very, very rapidly. So that's why you kind of see the water going crazy. And that's when evaporation happens because the molecules come very close to the top and the breaking and reforming is happening so fast that it just kind of almost jumps out of the pot and escapes. And in here I'm just showing how the bonds are formed and then they're broken. This is just really quick. Yeah. And here you can actually see the water boiling and start to boil more rapidly. And you can see the steam escaping from the water, where the water is going up into the atmosphere because the hydrogen bonds are creating and breaking so fast that it's all escaping.
And I think to myself, what a wonderful world. The colors of the rainbow, so pretty in the sky, are also on the faces of people going by. I see friends shaking hands, saying, how do you do? They're really saying, I love you. I hear babies cry.
Hydrogen bonds also play a role in transpiration through cohesion and adhesion. Cohesion would help keep the water molecules all together, and then adhesion would help the water molecules to travel up the plant by sticking to the plant cell walls.
The wonder and marvel of hydrogen bonding. Hydrogen bonds, buck in a pond, walking across, some looking lost. Why don't they fall in? Surface tension. Hydrogen bonds, hydrogen bonds, hydrogen bonds, hydrogen bonds. Small molecules, they aren't fools. They can attract, they won't attack. H positive, O negative. Opposite ends, they become friends. Hydrogen bonds, hydrogen bonds. H2O small, watch it liquid at all. CO2 gas, it's got more mass. H2O's got hydrogen bonds. Buzzing and cross, walking the pond. Capillary action you see, cause it must be a high ND electronegativity difference. Got polar ends, the molecule bends. The O at the joint, high boiling point. It's not volatile, just not in style. Hydrogen bonds, hydrogen bonds, hydrogen bonds, hydrogen bonds. H on one side, and O or F on the other. It's really polar, and attracts like a mother. Dipole attraction from hell. I love hydrogen bonds so well.
And I'll ever know. And I think to myself, what a wonderful world. Colors of the rainbow, so pretty in the sky, also on the faces of people going by. I see friends shaking hands, saying, how do you do? They're really saying,